Okay, in this section we're talking about exponential growth, which is anything that's an exponential equation, meaning the x is showing up in the exponent. So like this equation that I have graphed in red has an x in the exponent. It has some more nonsense, don't worry about that. Why I wanted to talk about this is that the news is currently dominated by the spread of the coronavirus, which is also to some extent experiencing exponential growth in terms of number of cases. It turns out that's not the whole story, though. It's not actually an exponential growth. It's something like this blue graph, which is called a logistic function. So there's some good news and some bad news associated with this being logistic and not exponential. First of all, looking at the graph, the blue one is way steeper, or it's a little bit steeper, and there's reasons behind that. Basically, exponential growth, you keep multiplying by the same number. Every time you take a step to the right, you multiply your height by a number, and then you multiply your height by the same number, and you multiply your height by the same number again. This logistic function, which is what's happening with coronavirus, is actually increasing in rate as time goes on, as opposed to the rate of change. The red one is kind of consistent. So that's the bad news, is that it is this blue shape and not this red shape that's going on and on. Here's the good news, though. If I change my zoom a little bit, the logistic function is very different from an exponential in that it has a maximum. And basically what this maximum represents is what's the total number of people that end up being infected. And so probably 2 is not the correct number, but it would be something like that. So that's the plus of being a logistic, is it doesn't keep growing forever. At some point it's got to level off. So it is getting steeper and steeper and steeper. And so this part right here is what actually looks like an exponential. And so when you see an exponential graph or something that looks exponential on the news, it's because we're still in this part, the early stages, which is unfortunately bad. It means there's more still to come. So what really matters to us is this maximum number. What's the total number of people that are going to get infected, that are going to end up affected by the disease? And so if we change the number L, which I have in the numerator, that's changing the maximum. What's the total number of people that are infected? Is it 4? Is it 6? Somewhere in between. And the K doesn't seem to have a super huge impact. It's just kind of making the graph wider or shallower. You may have also heard some talk in the news about something called flattening the curve. And when they talk about flattening the curve, to some extent they are talking about this guy being less steep, but mainly they're talking about a different graph, this black graph. So the blue one represents the total number of cases, which is a logistic function. And the black one represents the number of cases day by day. So in each particular day, how many cases were there? And so in this case, clearly right here in the middle is where we had our most number of cases. And so if I change the number L, it just moves both of them up and down together. It's not really changing. So the total number of people that get infected is actually not that important in terms of leveling the curve. When we talk about leveling the curve, we're talking about this number K. And this does have some pretty important significance, because if we have a number K like this means there's drastically more people showing up to the hospital on this particular day, as opposed to much less the days before and days after. So we want the curve, the black one, to be as flat as possible, so that the most number of people that show up to the hospital on a particular day is somewhat low. Okay, so that's what they mean when they say leveling the curve. But realistically, it's not going to affect the total number of cases. That's something that has to be dealt with independently. So both of these are going to be helped by preventative measures such as washing your hands, social distancing, which is the reason why we're not meeting in person today. Both of those are going to tend to decrease the K and decrease the L, the total number of people that get infected. Hopefully not everyone will get infected, and hopefully leveling the curve, we don't have as many people showing up to the hospital on the same day.